1-1. Where's my webcam now? 11th of our sessions on forest ecology with Mark Shepard. And if you haven't been here before, you're going to love this. This is going to be fun. You definitely want to go back and listen to replays. Mark has been with us and talked about things all over the world, but he's talked to us from Africa, he's talked to us from airports, he's talked to us from you name it. I've been in a McDonald's parking lot in 100-degree weather in Southern California. I've been in Yuma, Arizona at 120. We've done it from everywhere. We've got it made. If you didn't hear, we're actually under a little bit of a fire warning right now. We have a forest fire that's burning about a half mile from us, and it's going the other way, but we may get evacuated. This is Mark's show tonight anyway, so I'm not going to do anything other than just make this introduction. Quickly say, if you haven't done it yet, again, go into the replays, which are on the Economic Action Team site, and that is, I won't give the URL, I'll give it, but it's ceed.mykajabi.com. And you, if you aren't already opted in and you're registered for this, you will be. I will make you a member if you haven't, if you're here for the first time. Most of you have been here before, so you already are members. And I'm going to stop with that and turn it over to Mark.
Okay, hey, welcome everybody. Like Wayne said, as we're involved here in a exposition of the basic forest ecology curriculum. I just unplugged my computer. And I really do encourage you guys to go back and look at all of the, if you haven't gone through all of them, to at least sit through them again, because they're cumulative. What we talk about in each session is going to depend on what we learned in the previous session. And tonight, we're continuing. This is phase 3 of disturbance, how ecosystems change through time as they're growing and changing. Something happens to cause an issue in that system, and that's the disturbance. That's how we want to view managing our land as restoration agriculture, farmers and ranchers. And now why isn't my, there we go. Of course, once again, I got my original inspiration from J. Russell Smith, Tree Crops, a Permanent Agriculture. I've been interested in developing a permanent agriculture ever since I was in high school, believe it or not. Ran into the word permaculture, to the book Permaculture, and was trained in permaculture back in the early 90s. Eventually got my diploma from Bill Mollison himself. The phrase, though, that changed my life and really got my thinking totally different is this, that with permaculture, our aim is to design systems that are ecologically sound and economically profitable. And from my perspective, there really is no other thing that we need to work on. Because if we create a system that's ecologically sound and economically profitable, now we have time to deal with social issues and, you know, who lives where and all kinds of different other things. But if we don't have ecological systems that feed us and provide us with the goods that we need in order to get by, then what's the point? So my aim is to create systems that are ecologically sound and economically profitable. And there we go. Of course, David Holmgren reconfigured a lot of Bill Mollison's. They used to be called Mollisonisms, which are the permaculture principles. And where we are firmly rooted right now is observe, imitate, and interact. This is number one. Both Holmgren and Mollison talk about it. I stress it over and over and over again. We need to observe nature, imitate the systems, then interact with that. If we aren't observing nature, we miss the whole point. I just got a lengthy email from a person this morning talking about all sorts of different guild creation systems and protocols, and he's learned from this person and that person and this person and that person, and you know, there's no numbers on it and all that kind of stuff. We don't have to invent guilds. However nature got here, all the answers are for us already, but we have to understand, how do we observe nature? How does it work? And then once we understand what it is and how it works, then we can imitate that. And in order to observe and interact, we have to know the difference between an observation and a concept. Observation is something we see, hear, taste, touch, smell, measure with instruments. And if I give you a list that says how to observe this phenomena, you will observe the same phenomena as I do. You may call it something totally different than I do with a different name, but we observe the same phenomena. We'll talk about this later on. Remind me when we get to stump sprouts to talk about this again, the difference between observation and a concept. Wrote a book, Restoration Agriculture. Buy it if you haven't. Read it. Super simple. It's actually, it was just last week I found out that it's now being translated into Spanish, which I suspect is going to be even bigger seller than in English, because there are more people involved in agriculture who speak Spanish, whether it's in North America, Central, South America, Europe. A lot of folks speak Spanish, more than English when it comes to agriculture. Forest ecology, the scientific study, repeatable, observable study of interrelated patterns, processes, flora and fauna of systems that include perennial woody plants. It doesn't always have to be a closed canopy woods that many of you are familiar with, especially our Vermonter there. These open grasslands with trees, savannas, these all qualify. Basic rules of ecology apply whether there are trees there or not. It's just that we're talking about systems that include trees. And just because the forest isn't there now doesn't mean it doesn't function according to ecological principles. This grassland, rolling hills right here, is in a phase of site development. We've done a little bit, touched a little bit on succession. We're going to touch a little bit more on succession. This once upon a time may have been, looks to me like there's a lot of blowing sand dunes. It could have been drift at the end of a glacier. It could have been next to a lake or an ocean for eons, and now that sand dunes have developed. Or it could be a former desert area that's become moist, and now it's developing into a grassland, eventually becoming forested. And of course, the type of forest, the shape of the forest, the physiognomy of the forest itself is going to look different, whether you're in the tropics, the Arctic, subarctic, whether it's a dry site, humid site, etc. Now, ecosystem change, short-term ecosystem change happens in your lifetime and my lifetime. What we do when we're on the ground, planting trees, doing water management structures, building buildings, all of this is the succession of the site. And this is just some successional shots of my place. This is 20 years ago in southwest Wisconsin. Maybe a year or two after that, we can see some where are they? That's not one, it's a mullein. I thought there were some trees in the foreground here. Alternating strips. In between these strips, so there's a small grains, alley of small grains, alley of produce. Alley of small grains, alley of produce. In between, there's chestnuts. This ridge right there, we call that the South Ridge. That has a young chestnut forest on it right now. This was 2003, I believe it was. You can see how the site has developed a little more. You see all the different lines for the water management strategy. If we were that last shot, was looking across at this ridge, the alternating strips of grains and produce going down that ridge. A few more years go by, you can see the young chestnut trees growing. That's the same ridge here. These are successional changes until now here it's all grown together and you can almost hardly see the rows sometimes. This was just taken 2 years ago actually. Successional change. And managing that succession of the system, let's see if I can go back. Yes, I can. This right here, it's going to continue to grow. All these trees are going to grow. They're the locally adapted, mostly the oak savanna and northern hardwoods plant communities that we've planted here. They will eventually, with enough moisture and no disturbance, grow into a closed canopy forest with very little vegetation underneath, a thick duff layer, spring-grown ephemerals, lots of decay and fungus. This will eventually grow to a closed canopy forest, or if I continue to manage succession, I can keep it in a phase, an ecological phase, also known as a sear. I can keep it in that phase that's most advantageous to what I want to do on my particular property. And we do that through disturbance. We farm the successional process. We use the species, and we know that this process is going to take place. We're going to go from bare soil of a cornfield through the lichen and moss veins, grasses, herbs, and shrubs, whatever the species are of your place. This is actually quite similar to what could be occurring in Vermont. I fixated on Vermont because I missed the Northwoods right now, and I saw that someone was from Vermont. So we interact with our site, and we affect the successional process on our place with disturbance. And all through the eons, plants have moved across this continent in response to weather changes, glaciation changes, volcanic changes, river pattern changes. All of these species have migrated across the continent based on the disturbance. And ecologists define disturbance any kind of discrete event that changes the ecosystem, the structure, that's its shape, all the configuration, whether it's an open canopy, closed canopy, species composition, new species come in, old species get burned out or blown out or eventually become extinct for whatever reason. And it changes their functioning. Obviously, different species and different planting configurations will affect their functioning. We want to understand how the structure, species composition, and the function of our system works. And so we need to understand how disturbance interacts with our particular species suite and the disturbance regime that we use to manage our system. Disturbance includes landslides, major ecosystem components from the shape of the land, volcanism. Some disturbance events are repeated on a short cycle, once a year, twice a year, 3 times a year, once a decade, once every 50 years, or as in this case right here, once every 10,000 years or so, your mountain blows up, and then succession starts all over again. That's a pretty serious disturbance if you happen to have been living there. Disturbance includes soil erosion, flood, debris that's blown, banking collapse, and it disrupts the existing vegetation. This little place right here looks like it could be New Hampshire. There'd be more people living there if it was Vermont. Disturbance somehow disrupts this, and there's a whole host of different things that could disturb it, from wind to insects to disease, pest outbreak. When it kills organisms within the system, if we need to understand how the systems recover in order for us to learn how to interact with our own farm and ranch. If we know how our property or our suite of species are going to behave if they're trampled, then we know how to manage our animals in order to accomplish objective. We can use animals as a management tool or our equipment as a management tool and so on. We need to observe nature, how it works, understand these different disturbance regimes and recovery regimes in order to manage our property. I already mentioned the different scales from continent-wide to, single tree gets blown down. It can be from very infrequent, like tens of thousands, millions of years, to every single year. Disturbance affects the site by creating new landforms. It rearranges the parent material of the soil, changes the soil properties. It changes the light and the temperature regime. And with all of that affects the biota on our site. Now just think of all those different things I said. The shape of the land, rearranging the parent material, somehow changing the soil property, maybe by the addition of new mineral elements that came down in a flood, deposition of sand dunes and so on, different light configurations, different temperature regimes, all those different things, we can affect our site and affect all those little things. And when we, or one at a time, when we affect one of those things, how's our system going to respond? Knowing these things will help us to do our work as a farmer rancher far more efficiently and effectively. So much so that the closer we get to imitating a natural system, the less actual labor time and the less expense is involved in managing our system. But we have to understand how that system works in order to nudge it through time using disturbance. Here's a case in point right here. These were, I just saw these a couple weeks ago, high density chestnut trees that have closed the canopy now. With a closed canopy, the crown of the tree is getting restricted. They're not producing as many nuts per plant. The sun is starting to not strike the forest floor, and so we're not getting grasses. They're getting replaced by more shade-tolerant plants. Well, if I want grasses so I can have grazing animals in there, and if I want to have more chestnuts on my trees, I need to somehow disturb this site. And so perhaps I come in through and I act like a windstorm, poof, and I blow down 50% of the canopy trees and lay them flat on the ground. This is exactly what happened here. These are all mostly black locust. There's quite a few sugar maple that were in there, some American hop hornbeam, black cherry. But I just chop and drop, leave them on the ground. Leave them? Leafed them, left them on the ground. Of course, exclusion of disturbance is its own kind of disturbance, and the classic is with the redwoods in the West Coast. And actually, much of the Rocky Mountains and Western USA has had 60 to 80 years of intentional fire exclusion, which really has caused as many problems as it solved. Once upon a time, people thought, it's like, wow, gee, all these fires are ruining the trees. We need more trees to grow. It's good to let the trees grow. So you have these nice parklands, whether it's, you know, redwood parklands or ponderosa pine parklands in Colorado, then they all grow up with these younger trees, and as we'll talk later on, many of the trees that come up underneath are not fire tolerant. And that's kind of on purpose, because then they'll just burn out again. Well, the taller you let these trees go, the more danger there is to the large trees. And once these are big enough, you could light these on fire and kill every single redwood. Whereas in this open parkland, these young little trees will sprout up underneath, fire comes through, and it keeps it as a grassy savanna, redwood savanna. And of course, disturbances don't necessarily happen just one at a time, and their effects may be cumulative, their effects may be cyclical. Ice damage, for example, can break branches. It provides an infection site for disease, which weakens the tree, which becomes susceptible to insect attack, and then an affected tree doesn't survive a drought, which kills the tree. Well, which disturbance actually killed the tree? All of these things work together, and for us to understand that it's not the most obvious thing, it's not the bark beetle that wiped out these sections of forest. The bark beetle is one piece in a big, huge cyclical cycle of cycles. We need to understand them. Most plant communities don't start completely from scratch. Our surviving organisms are the biological legacies. No matter where you live, there are biological legacies right now that will be providing a certain amount of biotic inertia to change away from what that system is. Whether you're in Vermont or Kansas or Missouri or Texas, the trees and shrubs and bushes and grasses around you, they're sending seed in. There's pests and diseases that are associated with those plant communities. And if you try to establish a new type of system altogether, you're going to be taken over with all the natural things that are coming in, invading your beautiful little system. So understand the importance of biological legacies and try to work with them instead of fighting against them. Remember, human disturbances are still disturbances. They may be a lot more damaging, but they are just merely disturbances. They'll only be here for a short, a couple thousand, or in the case of the Hanford facility, nuclear waste, maybe a million or so years, no problem when it comes to a planet. It's kind of a problem when it comes to us. And you can see here, even on this mining site, there's still legacies around here to reseed this. As soon as the people are gone, the process is going to start. Succession is going to start over to clothe that site with trees. Some of the physical legacies left behind are bare soil, for example, rearranged mineral soil, new microtopography as a result of uprooting, debris flows, and so on. So legacies, whether they're biological legacies or physical legacies, these are what set up our next successional direction forward. So the pictures I showed earlier of the chestnuts that were too thin, I thinned out some of the chestnuts, removed a whole bunch of locusts. The legacies are the chestnuts left behind. And of course, the grazing animals that I'm going to bring through there and the grasses that remain there, they're going to drive the next wave of succession forward. So we can at least plan, years, decades, even centuries ahead. I have a part of my farm that I planted probably 15 or 16 years ago, knowing that probably between their mid-20s and mid-30s, might decide to build a home, and they might need lumber to build a home. So we've got land that would be paid for, and we've got the material to build a home out of. It's all right there. We're planning ahead and understand how to manage that site with the type of disturbance that we introduce to it. All right, so wind has an effect on the macro and the micro physiography. These are the Warren Dunes in Michigan. The sand, some of the biggest sand dune piles I've ever seen. Is quite amazing. Obviously, if you're buried by a sand dune, that's a disturbance to you and your local system, but new successional pathways happen. New process. I showed this a couple of weeks ago when we were up in Minnesota. It's not all that easy to see, but all along this ridge, wherever we see the white sticks, there was quite a significant blowdown up in the Boundary Waters a few weeks ago, and we went up to film it. Like hundreds of square miles of trees just snapped off. Obviously, this has rearranged the structure of the ecosystem. Different plants are left behind to survive. One of the things I wanted to talk about a little bit, there's a permaculture teacher online who made not a mistake, he just invoked my name as support for an argument that he was making. Well, unfortunately, he was arguing against observable phenomena, and he was talking about soil development, and it's taught quite widely that you never, 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 never disturb the soil, because that's what ruins the soil. You have to leave the soil undisturbed and somehow figure out how to plant into that, use mulches, sheet mulch, lasagna gardening, all kind of whatever. And then there's a lot of people also that whine that swales and berms are not, are not necessary or even important. Well, a couple of things right here. When a tree blows down, root plate rips up and tree falls over. The root has its own organic matter, the duff on the top, plus mineral soil, rocks and chunks that are in it, and it slowly decomposes over time, and you end up with a pit. It's like our swale, and then our berm. So what happens is we've ripped up this root system. We've exposed the mineral soil in the pit. This is new planting sites. New plants can get established here. New organic matter can accumulate. This is creating better soil using disturbance. Well, then this mound, this is now a mix of rocks and debris. We'll show some pictures in the next couple of slides. You've mixed these rocks, which were below the level of where they would be acted on by oxygen or rain or freezing. So when you uproot the tree, all these rocks and the soil particles now get mixed thoroughly with this organic matter and actually can accelerate the production of a rich, thick, diverse topsoil. So what I wanted to point out in that particular case right there is to observe phenomena. Let's observe nature. What is nature doing when it is doing this? What's happening here when we have a depression that now can collect this organic matter that decomposes, that can have a little bit more moisture in it, and so these little tree seedlings can get established? Seems to me that this little depression in this particular case, in this context, with these species, helped these trees to get established. Well, now we see that the mineral soil got thoroughly mixed with organic matter, and it's going to slowly decompose in a pile. So we have an example here of what happens. I'm not saying this is good or bad or right or wrong. This is an observable phenomena that right here, this is going to be a richer, more fertile soil in another 5-10 years as all the organic matter decomposes. There's more air in here for aerobic bacteria and fungi, obviously a lot of fungi in the roots, and these pieces of rock and the small chunks of gravel are all exposed to the oxygen. They're going to start to oxidize. The acids in the rain, humic acids, are going to start to dissolve the minerals in it. This type of disturbance actually over time will create a richer soil. Here's those little trees getting established. And I already mentioned all this. As the roots decompose, organic matter and minerals become mixed, and so on. And the decaying tree is some of my favorites right here. Now, gaps created by this disturbance allow extra light to come in and extra rainfall. So now it's enough for these species that have to have sun, allows them to grow a little bit faster here. Doesn't matter necessarily what opened up that canopy. We just understand how opening the canopy will affect this little group of trees here. Now we're getting to the exciting part. The wind, of course, tends to remove the overstory trees. A lot will ring off. They'll snap up the top. A lot will fall over, whereas fire tends to remove the understory. Of course, when the fire climbs all the way through the trees and crowns out, that also will remove overstory. But those actually are the exception. They're not as common. So there we go, fire. How's the fire coming along? Wayne, update? He's not listening. So fire worldwide has been observed to be the dominant disturbance factor in landscape history worldwide. Every climate, even in the tropical rainforests, even swamps will experience fires. This is a place where I took a picture of this is 1 year after a burn up near Ely, Minnesota, west of Ely, Minnesota. And notice that a brushy layer has been removed. The taller trees that have to have a little thick, they managed to survive. Or if they had shed their branches real early, like these pines, One of the fire strategies is when they shed their branches young, they fall to the ground. There's no what they call ladder fuels that allows the fire to climb up like that, climb up to the top of the crown of the trees. It just burns on the ground. Part of what's significant about fire is it doesn't just wipe out massive acreages uniformly. Even if it covers, 1,000 acres, for example, the whole 1,000 acres got burned somehow. Different parts of that 1,000 acres got burned with different intensities. And it's a heterogeneous effect in that you're going to have these random patches. You can have more of the pre-existing vegetation that's totally intact. In some places it'll be seriously burned to the ground. And that's all part of the whole diversity dance that allows that site to have more species diversity, because you can have different niches available. These types of trees here provide habitats for different plant or insects and plants and fungi than these types. This much underbrush, it provides additional habitat, but this doesn't, and so on. This a mosaic of landscape forms is set up by fire. And as a selective force, it brings about different responses that biology has. I'm talking mostly to plants here. It obviously affects animal communities, but most animal communities they'll either run and go away, and if the place is no longer suitable for them, they will try to migrate to someplace else. Others will try to hide, dig in, and survive. A lot of the burrowing animals you'll see, like raccoons, obviously squirrels and chipmunks, woodchucks, a lot of denning foxes and cats and so on. The different woody species have different survival techniques and reproductive techniques. One is asexual reproduction. All fire-dependent species will sprout from the stump. If you cut them down, they'll sprout back. If you burn them off, they'll sprout back. Stump sprouts are common in so many different species, some of which aren't very happy with fire, like the lower right here with beech and maple. The tree itself, if a fire goes through, it's very likely to die, versus an oak tree that has a thicker bark it doesn't burn out as much. It doesn't kill it as likely. So what we see here, all these stump sprouts coming from this birch, and whenever you see clumps like this was once upon a time a tree in the center. It was either cut and removed, or it was burned out, and then maybe where you live, this is a 5-year-old birch tree, maybe it's a 20-year-old birch tree. Up in Alaska, that would be about an 80-year-old birch tree up on my homestead. And we can observe this phenomena in the species that live with fire. One of the things, back to the observation and concept, I went to a workshop on trees. A lady was teaching on the spiritual lessons of trees. Well, I feel that trees have a lot of non-material values to convey to us, and so I wanted to go see what her shtick was all about. And we were walking through the woods, and all of a sudden we came upon a clump of trees just like this, and she gasps and she says, "Oh my goodness, everybody stand back! This is a power vortex." And she explained and waved her arms all through the air of how this power vortex caused this phenomenon in the trees. And quite plainly at the bottom, I could see the stump. I didn't want to make her awestruck minions disappointed, but her explanation of this power vortex, if she had a way for all of us to observe this power vortex, that I could give you the instructions of how to observe this power vortex over and over and over and over again, I'd believe her, because it's an observable phenomenon. One of the things about this right here is you can go look. There's going to be remains of a stump in here. This is stump sprouts. It's a fire response. Also root suckers. One of my most unfavorite trees of all, the black locust, has tremendous root suckers. And if you have like hybrid poplars at all that you've used, or even cottonwoods, they'll have these really shallow surface roots, and if you're trampling animals over them or mowing it, you clip them at all, they'll start to sprout up again, and these can be a real royal nuisance. But a perfect fire survival strategy. If a light grassland fire comes through here, those trees, the tops of these little trees, will burn off right to the ground. The prairies actually were difficult to plow, in part because of the dense sod. But if you read the writings of some of the early naturalists, and I'm remembering John Muir specifically, the prairies were really difficult to plow up, not because of the grass roots, but because of what they called grubs. There were these ancient root systems of oaks, for example, and hazelnut that were growing in the grass, and it was a prairie. A fire goes through every year, maybe as infrequently as every 3 to 5 years. It'll stay as a grassland, and you don't realize this little tree grows up, and then a fire comes by, kills the top. The root stayed alive. Tree grows up, the root gets a little bigger. So year after year after year of fires are burning off the top. There's never any top to these trees, and the root system is gigantic, and you couldn't get a plow through it. What happened in Wisconsin and a lot of places, all across the Midwest actually, is those areas then were let go, and the forest that was there, just not above ground, boom, sprouted up. It's a fire response. That survival technique, those trees are there, they're going to do all right. So you can see these root suckers coming up. These are on aspen. Some of the largest organisms on the planet are actually aspens. They're all the same tree. Genetically the same tree, all connected by an underground root system, totally fire-adapted species. One of the responses, or the one of the characteristics that's favored by fire is sexual reproduction, especially with trees that have light and wind-blown seed. Willows, cottonwood, aspen, birch, most of the pines. This island right here that I took a picture of in Boundary Waters a couple of weeks ago, that island is actually called Burnt Island. Well, Burnt Island, why is it called Burnt Island? It's got 2-foot diameter trees on it, white pines. It also shows evidence of wind throw, that all kinds of trees had snapped through the years, and just the tallest, most sturdy pines that leaned a little bent with the wind remained. This started, I think it was in the 1920s, when that island was burnt, completely burnt. Well, this seed floats in on the wind, and it finds some exposed soil, which we'll see later on, and it grows really well with very little competition. One of the things that also happens with fire-tolerant species is they have a higher of self-fertilization. The prunuses, for example, cherries, plums, apricots, they can self-pollinate. Same with pines. Pines have a high percentage, so much so that red pine almost doesn't need any pollinator other than itself. Obviously, once it pollinates with itself, there's been a slight genetic change, and so the diversity does kind of increase, the genetic diversity for a period of time. But most trees, if they have a lot of self-pollination going on, they'll grow a little bit more stunted, not as vigorously as open pollinated with other tree pollen. And it's obvious too that fire, as it goes through, is going to cause a reduction in competing vegetation for fire-adapted species. If you are one of these little species here that can survive a fire, your life is far better without all this competition around you. Whereas you're not growing up in a thicket. This is probably a big, huge thicket. There's lots of debris on the ground that was in the way. What I want all of you guys to do as we're going through this exercise is to think about how these different trees and plant communities respond to fire. Well, now, how do they respond to fire? And if this is a response that we want, if we want to have reduced competition for a particular type of vegetation, perhaps an entry into our sites that resembles fire very closely, or maybe fire itself, will create those conditions for us. If we want to have a place that looks like this, how was this created? How can we create this in a very cost-effective, economic manner? And how can we have a vegetation respond this way? We need to understand how these different systems behave with this disturbance, and let's imitate this kind of disturbance if these are the effects we want. I'm not saying that fire in your system is good versus bad, or that you should cut trees down here or not cut trees down there. What I'm saying is that observe the phenomena. What does fire do? It does all these things we've talked about so far. One of the things that it does is, here's another thing about the mixing of soils. What happens is in a lot of fires, especially on sloped ground, you don't have any more surface plants with the fibrous roots holding the surface together. And if a big rain follows, there's all kinds of mudslides afterwards and debris flows. So now what happens if there was an unburned place, unburned area downslope, and all this debris, whether it's dry drifting or wet drifting down the hill, all this new ash and mineral soil moves on top of this layer of organic matter that was the grasses and the other leaves in the system below. We have a mixing again, and we've prepared a seed bed. This is perfectly prepared seed bed for specifically the light windblown seeds that would come in to a burned area. So what it does is it will reduce the organic matter. Fires will reduce the organic matter into its basic constituents and cause nutrients to be available that weren't before. Wood ash is fairly alkaline, so it'll lower the pH, which causes a lot of the decomposer organisms to really kick into high gear. Those of you, especially in the drier areas like Texas and Colorado, California, what's going on in Colorado for sure, and in California with these catastrophic fires that are going on is if anything dies out there, there's so little moisture to do the decomposition that you have all this woody debris that piles up and piles up and piles up. Also happens in the far north up in Alaska. The decomposition rate, there's enough moisture for decomposition to take place, but it's just slow, and so you get an accumulation of organic matter. Well, if you have plants that need mineral soil to get established, many trees need to have that bare mineral soil. How do you get your seed in contact with the bare mineral soil? Maybe you burn off all that organic matter, temporarily lower the pH, you get some bare mineral soil, you get your little plant established. Now it's got water-soluble nutrients available, less competition. It can really take off and get established really quick and easy. So exposure of the soil is natural. It's a normal kind of disturbance. How do we use this on our site to accomplish what we want? What happens quite frequently with fire adapted species, excuse me, I'm thirsty. Fire adapted species, like the pine, like the aspen, like willow, will come into a site that's been disturbed like this, so a lot of bare soil exposed. Millions of seeds come in. How do they say in the vernacular? Yeah, a lot of seeds. And they grow really thick, like fur on the back of a cat. One of the things about this is this creates the next fire hazard. Look at the wide spacing in these larger trees. These larger trees were left behind. These are the legacies of this site. Well, there are all these pines that require the fire. Jack pine is a classic. How it depends on fire for its regeneration. So it just cast tons of seed on this bare exposed soil. Now think about what's happening here, and this really relates to a lot of what I talk about with planting a system wherever you live, is if we're going to go plant any kind of woody species on our farm, we need to plant lots of them because we are planting mostly seedlings, because we are intentionally using the process of sexual reproduction to create variation in the offspring. Yeah, we may want to have some clones because they have a predictable crop, size, flavor, ripening period, harvestability, all that kind of stuff for uniformity. But we want and we need genetic variation in the planting because we want to have the abilities to survive no matter what kind of insult nature throws at us. There's going to be species in this picture here that are more disease resistant. They're individuals that would be called varieties. Individuals that are more resistant to fire, that grow faster, straighter, taller. There will be individuals that produce more nuts, seeds, bigger seeds, smaller seeds, and so on. We want to have the total number of plants on site for that genetic variability. And we get to choose, because we're the site developers, we get to choose which ones that we want to keep behind. Well, in a situation like this, all of this fire right now, or all these trees right now, are a serious fire hazard. Next fire comes through, thins it out again, and it thins it out. Maybe this stand right here was burned, 4, 5, 6 times by the time these trees got to be this big. Actually, there was somewhere I was just reading recently that the Boundary Waters itself had a fire period of about 3 to 5 years. Every 3 to 5 years, there would be a fire at any one site. If you just stood there for 5 years, you're going to get a fire within 5 years. Pretty fascinating, I think. Another thing that fire does, in addition to allowing high density pure stands to be planted, when you have these dense stands and fire hasn't come through yet, you now get extra humidity gets built up in there. You have extra sites for insect outbreak, disease outbreak. So fire-created sites favors the establishment of dense, even-age stands like here. Fire goes through, seed goes down. They all were planted at about the same time naturally. So they grow even, they grow fast, same species. They're more susceptible to disease and insect outbreaks. So now you got bark beetles or spruce budworm. Now you've got all this dead and dry material here. Boom, one little lightning strike or one little Colorado camper, and we know what kind of cigarette butts Colorado campers have, leads to additional fires. And once again, once you burn these trees out, you're going to get a dense stand development of a similar kind of fire-dependent species. And different sites with different moisture regimes will have a different fire period, how frequently the fire comes through. Basically, if you got anywhere that's jack pine, you're going to have a fire within 50 years. You just will. Get over it. Same with lodgepole pine. The ponderosa pine is it actually wants to have fire. It's a fire-dependent species. It's not as flammable as jack pine. Jack pine kind of burns on purpose. We'll talk about some of its survival strategies probably next week. Fires will also help to eliminate parasites like mistletoe. So how do we understand what's going on here? We get this dense, uniform, even-aged establishment of this species, pretty much a single species, maybe a couple, 3 at the most. How do we use that? How do we use that as a genetic selector? Then once this happens here, how do we deal with the fact that now we have this big, huge fire hazard? Maybe this is the time to log. If we don't want it to burn. If this is our own homestead, maybe we start to thin this out now to make it less fire susceptible in the future, and shred this material, inoculate with mushrooms, etc. How do we understand how these systems are going to work? And if you live in a place like this is just something you're going to have to deal with. Fire is a part of it. Now, eliminating parasites, mistletoe. You may want to eliminate them because you don't have as good tree growth. It's not as straight and as tall. These trees obviously will grow slower than if they had green all the way down. But we also want to think about this. This is actually a very useful product. Anybody who has Christmas and people who kiss each other, you could be selling mistletoe for the holiday season. And actually, I've worked quite a bit with growers in Oklahoma, actually supplying mistletoe to medicinal herb companies. It's used as an anti-cancer compound. I don't exactly know how it's used, but that's used in the herbal cancer apothecary. But fire tends to retain the fire-dependent species on an area. So if you're in an area that like is ponderosa pine or jack pine, it'll burn through, the seeds will come down. It's favorable conditions for that species. And the jack pine will regenerate. And then the fire comes through and the jack pine will regenerate. The southern pines, red pines, white pines, lodgepole pines, oaks of the whole oak savanna region, whether it was California, the whole southwest oak savanna, the front range of the Rockies oak savanna, or the whole midwestern humid oak savannas. The oak is not like the most shade tolerant late successional species. It's a mid successional species, but it was maintained by repeated fires, and of course grazing and browsing was thrown in there as well. That these fire-dependent species in an area where the fire is kept burning at a regular interval or irregular interval, if the case may be, but within a certain fire period. Each different trees will have a different fire period that They want to have fire more frequently than this, but less frequently than that in order for them to regenerate. And all of these different species I just mentioned are different. And if the fire regime changes, the whole successional pathway changes. So like in the Rockies, for example, Engelmann spruce is not very fire tolerant at all. Douglas fir is a little bit more fire tolerant. Ponderosa pine is very fire tolerant, and eventually have these beautiful ponderosa pine savannas with the grasses underneath. Well, if the fire is even more frequent, even these trees will get damaged. There'll be fewer and fewer ponderosas, and it'll eventually turn into a grassland. That's the fire's more frequent. Less frequent, it'll be more Engelmann spruce. Well, then if it goes the other way around, if we decrease the fire frequency, we can shift from total ponderosa pine like here right now, then all of a sudden are less fire or are more fire sensitive. They would burn out. Species will grow up underneath, and then eventually these guys, the ponderosas, won't have anywhere to seed because they need it to be burned and bare soil underneath in order for them to propagate. So then it'll become Douglas fir and eventually Engelmann spruce. So what we end up with all these different disturbances interacting with one another and with fire. Even if fire burns 1,000 acres, a square, flat 1,000 acres, it will not burn everywhere with the same intensity. So you have a mosaic of different age classes left behind. And this is part of how we carry species forward in time, that if we burned it all uniformly, we don't have that species represented anymore. That actually might, that one particular insect might play an important control role in some of our other plant life cycles that are going on. We can maintain as many of the total species diversity of our area on our site if we have a mosaic of age classes, sizes, physiognomies, shapes, configurations, layouts, etc. This is the way our continent worked for zillions of years before Europeans got here. And I'm going to show this one again. I mentioned it briefly with the ponderosa and Engelmann spruce. Typically, the species that come in the understory are more shade tolerant. They have to be shade tolerant, or otherwise they wouldn't survive in the shade underneath these red pines. These are red pines that are sun-loving. They're a fire-dependent species. If there's a lot of wind throw, they'll get established. Their light seeds will float and land on the mineral soil. They'll get established that way as clumps. But in a large swath, if you got a large stand of red pine, that was a catastrophic fire. Seed blew in, they got established. Well, then underneath, they can't get established in the shade, so it's not red pine that regenerates underneath them. This is mostly balsam fir and eastern hemlock, both of which are extremely susceptible to fire. And so then what happens is these nice tinderbox trees provide the fuel for the fire to come through, clean it out, and keep it dominated as red pine. Or, once again, if these get too big, and the fire comes in, climbs right up, and it can torch out the crown. Now you've eliminated both species, you've totally changed succession. So just looking at what we have here for opportunities. We have these red pines that are dominating the site. If we want to keep this a red pine dominated site, we can remove the understory. One easy way to remove the understory is through logging, or another way is through burning. Then we have a red pine site with these trees that are going to grow faster and thicker. Maybe we open it up enough so the grass grows in underneath. Now we're grazing cows in a pine silvopasture. That's one option. Another option is just let this go a little bit longer and then remove the red pines. And then we have balsam fir and eastern hemlock and white cedar coming up underneath. And then we manage it as a cedar fir grove. The firs are rather short-lived. They would come out first. Some spruces that were in there. And hemlocks are longer lived. They could come out spruce maybe second and then hemlock third. So we have a whole different range of successional directions that we can send the site depending on what we choose to do with it. So once again, this site in a natural fire regime, it will tend to stay a fire-dependent site that's colonized by fire-dependent plants will tend to stay that way. A red pine site will tend to be dominated by red pines, white pines, lodgepole pines, etc. Because all the understory brush as it grows up will tend to burn off. Now the stand habit the configuration, see the spacing between these, this will determine how that particular stand of trees will be affected by fire. If you have a super high dense stand of trees and you get a fire in that crowns out, that whole section is wasted. That's like the wasted meaning destroyed, not like gone to waste. If you have a species that are intermixed with one another, a fire can come along here and burn through and probably not kill everything. So if you're going to be affecting the ground level beneath trees like this, the stand habit, the spacing, the spatial configuration of them has everything to do with how well they'll survive your disturbance, whether it's grazing or haying or burning. Now, the site conditions, so here we've got all these fire-dependent species here. The site conditions at each site determines which trees are able to reproduce. And like we mentioned here, these red pines here require some kind of wipeout to get rid of these understory trees. They need those understory trees to go away and expose the mineral soil. These trees require plowing if you have it that way. They need bare, exposed dirt in order to sprout. If fire comes through frequently, that's going to affect the selection pressure. Infrequently is going to affect the selection pressure. What's going to happen is the species that are most adapted to that site, those characteristics that allowed them to survive that regime propagate within that system. So if you want to get some really fire-resistant oak, for example, go to a place that's like a real dry, sandy area that gets burned frequently. They may reproduce really fast. They grow on really lousy soil, and they may start having acorns when they're really, really tiny. Look to the tougher, more rugged sites for super crazy genetics. Here's a tree that grows and reproduces without any soil growing in the crack in the rocks. Obviously, if you're in a place that looks like this down here on the left, don't try to grow bananas. You know, I wouldn't mind having a tree like that on my farm, this big, huge one. Next week, we're going to talk a lot about individual fire adaptations of different plants, different things that you can look at and recognize. These are adaptive strategies. And then what's kind of really significant for many of us, this is especially North America centric here. We'll talk a little bit about some of the plant communities in North America, specifically the ones that are more fire related, that have a fire history. And so if you live in the northeast of Lake States, anywhere where there's the western pines, ponderosa, aspen, or if you live down anywhere in the south, mid-south, central south, Douglas fir in the Rocky Mountains or on the west coast, giant sequoia on the west coast, boreal forests in Canada, Alaska, the northern Rockies. If you live anywhere here, understanding how these ecosystems work, how disturbance affects these systems' reproduction is key to your figuring out how to imitate a system like this to produce your own food, fuels, medicines, fiber, and it also will help you to learn adaptive strategies so that if you happen to live in the front range of the Colorado Rockies and there's a fire right over the ridge, you might say that, hey, man, I'm all set because I planted my system this way, I have my water management, swales and berms that way, I'm okay, I'm not going to get burned out. Or, hey, I'm looking forward to a fire, I want it to come through, instead of having to, be seen in the evening news getting lifted from your roof by a helicopter. Not that that would ever happen. But one of the things, now if we understand the disturbance regime, and like especially next week I'll talk about these systems right here. If we understand the species composition of our region, and if we understand the disturbance regime, we can imitate that in our restoration agriculture system. And I'm going right to this right now because one of the most, what I think is quite a dramatic example of mega large-scale industrial agriculture is actually restoration agriculture. And those are the blueberry barrens. The state of Maine, USA, is actually the world's largest producer of blueberries. They're mostly low-bush blueberries, and they grow in crap like this. This is obviously not high-quality agricultural land. It's stony, some of it's sandy, some of it's boggy, and it's an extremely fire-dependent system. What would happen on these blueberry barrens here is it gets so hot and so dry certain years it just torches up, and very few trees survive on it. It's a lot like the heathlands in the UK and whatnot. And so what happens is growers of lowbush blueberries in Maine, they imitate the natural processes, and they intentionally burn their blueberry fields. All different kinds of machinery, they're imitating the effects of fire by actually using fire itself. This is actually, I think, one of the most brilliant agricultural strategies at the industrial scale that humans haven't even realized that they're how ecologically sound this production technology actually is. So we'll start to talk about these different plant communities, their different disturbance regimes, and then how we might imitate those in our own system. And let's just keep in mind the blueberry growers right here, how they're imitating nature and growing blueberries in barrens and burning them. And that's all I have for this evening. And I'm just going to leave it at these pictures because
awesome.
This is right up the road. This is right up the road from the blueberry barrens, and there was this was a series of clear cuts 30 years ago. And what one guy did, I didn't take pictures of this last time. I should have done that. With his clear cut, he immediately went through with a bulldozer and he just pushed all of the slash into piles and all the stumps and just burned it, lit it on fire. And it was really depressing. A lot of people, got irate that this guy, it's already abused and he's abusing it more. Well, then what he did is every 3 years he'd just burn it again and then burn it again. And lo and behold, it was about 10 or 15 years later, blueberries came to dominate the site. He's got like a 400 or 500 acre blueberry, this big, huge, bald hilltop. It's all in blueberries because they were the ones that were able to survive that disturbance regime. So that's it for the evening. How about questions?
Awesome. Well, we have a few questions, Mark, and a couple of them are probably more relevant next week, but some of them are some clarifications. Somebody asks, what is a management technique pre-fire to protect from crown fires, which can destroy the legacy species, redwood, pinyon, ponderosa, that we are managing for?
Yeah, that's a great question. And so one of the things that, if you just remember a phrase, is ladder fuels. What you want to do is eliminate the ladder fuels. And so what those ladder fuels are, if you look at the slide that's right here, you see all these little white spruce that are underneath, highly flammable. There's some white birch that's got the paper on it that'll light on fire. If any kind of grass fire comes along in here, these are butternuts. There's butternuts and there's some oaks in here and there's some chestnuts. They would tolerate a light ground fire, but all of a sudden the ground fire comes in, boom, climbs up these small flammable trees. So remove a lot of the smaller flammable trees, and then on your larger trees that you want to keep as legacy trees, start trimming the branches up. And if you're in a drier area, and there's actually, if you go to the Central Rocky Mountain Permaculture Institute in Basalt, Colorado, there's one hillside, about a 5-acre hillside that we did in 1993. We removed all of the ladder fuels, all the branches on the bottom 8 feet, 10 feet of these pinyon pines. Then we laid them down horizontally across the slope, and then we dug a little swale and we buried the sticks. So just think what we just did. We imitated pit and mound architecture. We took those sticks, which are a fire hazard because it's so dry there, and we got them buried with some soil. So now there's a little bit of moisture holding capacity. They start to decompose more quickly. Then you've got the pit that starts to accumulate organic matter, leaves, rabbit turds, seeds get established in those little pits. So to remove the ladder fuels would be helpful, whether they're branches on your legacy tree or the understory.
And guys, we're going to be putting some videos on. Mark was here at my ranch a little less than a year ago, and he did a couple of really cool videos because I have a ponderosa-dominated legacy situation. And I fired about 10 years ago. That fire took care of the ladder fuels for the most part. Remember, Mark, you pointed out what that went on. But I have a portion of my grove that I still do need to remove some of those ladder fuels. And that's a management strategy that Mark talks about. The video shows exactly what we should do with it, just the way you described that. So, we'll be posting those or putting them in so that we can get some info from them. The next one is how much of a hurdle, this is one I can answer for Colorado here at least, is there to having a controlled burn to getting the governing body's approval? Totally dependent on their fear that you're going to not know what you're doing and that you burn something that causes the fire to get out of control. It's actually very easy to get a controlled burn permit here in Colorado if you follow the rules. And it's not going to be, they'd like you to do it. You're not going to get it during a fire ban time of the year like we have right now, but it's a pretty simple process. Here's a good one. What was...
I was going to go to that same question though. Wayne. One of the easier ways to deal with that too is to just hire a contractor, somebody who does it, then they've got the insurance that covers it if the fire gets out of control and it's not your fault.
Yeah, that makes total sense, right? That makes great sense. So another question is, what is the term phase that you used? How did you spell it? And then you just said also question mark tier. I would know when you were talking about that.
S-E-R-E, and I just kind of like used it by accident, but yeah, it's a SEER, it's the ecological phase. Let's see if I got that. I don't have a glossary handy, but yeah, somebody look that up. Make sure I used it right, because if I didn't use it right, correct me. We all learn here, you know. So yeah, it should be the SEER.
So here's one comment from someone. I've seen people limb up pinyon pines and junipers. A lot of work, but then you have the loads of organic matter to improve the soil. This is somebody said. He's agreeing, I think, to what you were saying.
What's also nice about that too is you're removing the branches down low, so as the tree grows in diameter, there's no more branches in it, so you'll have knot-free wood, and it's a lot more valuable as a timber log when you eventually do use it for timber. So it accomplishes a lot of objectives. It also helped to remove, a lot of disease sites, a lot of crooks in the branches where disease can get in. Different kinds of fungal things can get going on there. And if you have branches on trees, let me see if I see any, this picture right here. See right over here, if you can still see my screen, how steep that branch is, that angle right there. Those can tend to get snow load or something like that. They're more likely to break. So you can get you take these branches off, you'll have a straighter log, no knots, branches that won't, crotch that won't split, and no ladder fuels.
Cool. Well, one more, and then we'll let Mark go, everybody. This has been great. Put in a 1 on your here if you enjoyed this tonight, everybody. So this one, I think, is back to the same question related to phase and SEERs. How frequent or infrequent are you talking when you use those terms? Perhaps you could give a few examples of specific types of forests or their appropriate burn intervals, just to give us an idea of the norms or extremes. I don't know.
I guess what I'll do right there, I'll talk a little bit about that right there, is the fact that everywhere is different. Absolutely everywhere different. And to think of a norm is classic Western reductionist materialistic thinking, and it's not observing nature. There will be a norm on a site, and it's site-specific. It has to do with the landforms, the climate. It has to do with the orientation, north, south, east, west, where the wind goes. It has so many factors involved that there's no such thing as a norm. It's totally site-specific. Yeah, you can get regional guesses and ideas. So no norm. So everywhere from every 1 year to every 500 to 800 years.
Great info. And lots of ones here. Somebody put 1 with a whole bunch of exclamations. Thanks to everybody. Let me just throw something out real quickly. And this is for one person out there, and he'll know who he is, Jeff Lee. Jeff, if Jeffrey has not gotten back to you yet, he's going to be getting in touch with you about the conversation that you and I had. So, and Mark is also aware of it, so we'll check with you when we can here. Mark, that's awesome again. We're going to continue with fire, it sounds like next week a little bit, Mark, right? And also with other disturbance.
Yeah, it'll be
let's go ahead and sign.
how those systems behave, and fire is a part of those systems.
Okay, cool. Well, again, the replay will be up sometime tomorrow. You can go back and look at it. Again, if you're not registered yet, we'll get you there. And Dustin, thank you so much for saying thanks. Appreciate that. Thank you for all of you. Thank you for our staff, Mark out there in Bangladesh, and for Stephanie. Stephanie, say hi. I was going to let Stephanie kind of do all the end of this, but this fire sort of kept me in the house where it looks like they got it under control. There's not nearly as much smoke now, so it doesn't look like we're threatened today. By the way, Mark said it. We actually have prepared. I'm actually at the point almost where I'd like the fire to come through in our area now. We'll get to that point. So thanks, Stephanie. Thank you, Mark, and we'll catch everybody next week. Bye.
See you next week.